All right, this video is going to start on page 10 in your packet. So we're going to continue looking at velocity versus time graphs. Okay, so on here, first thing we're going to take a look at is types of direction. We're just going to keep practicing that. So anytime I'm going away from 0, okay, that is going to be speeding up. Okay, and anytime you're above the x-axis, that means you're going forward. So this would be speeding up forward. Now, when I hit this 5 to 8 second area, this is going to be a constant velocity in the forward direction. So meaning you got 0 acceleration, you're constantly at 12 meters per second. And then at 8 seconds is where you got to be careful. It's not that you turn around, it's just that you start to slow down. Okay, and you're still going forward, you're just slowing down because you're approaching 0. Okay, so remember this x-axis, you got to really pay attention to this x-axis here because that is your 0 line. Okay, so number 1, what is the maximum velocity attained? So remember, velocity is going to be your y-axis. So you're just looking for the highest y value. So that would be 12 meters per second. At 2, what time is the maximum velocity attained? That is going to be your 5 to 8 seconds. Okay, so that's just when you're going the fastest. What is the velocity at 6 seconds? So again, this is just going to be 12 meters per second. We're just going over kind of different ways we can ask certain questions. So pretty much if I ask anything about velocity, you need to be looking at the y-axis. Number 4, when did the driver turn and decide to return home? Okay, now some people are saying at the 8 mark. Okay, that is not a turn in direction. That just means you're slowing down. You're starting to head towards 0 in the forward direction. 14 seconds is technically if you stopped. Now, in this graph, if this graph kept going and you kept going through the x-axis, then that would be a change in direction because now you're going from a positive velocity to a negative velocity. But since our graph never really went into that negative, there was no change in direction. So it actually never occurred in this graph. Okay. When was the velocity constant? So that means we're looking for a flat line. Okay, so remember your slope here is acceleration. Okay, so if I ask about velocity, okay, or acceleration would be slope. Velocity is going to be your y-axis. So if I want to know constant velocity, that's just when I have a flat horizontal line, so that would be the 5 to 8 seconds. What was the average velocity from 5 to 7 seconds? Okay, well, if my velocity was 12 at 5 seconds and 12 at 7, my average is going to be 12 meters per second. Okay, moving on to the next graph. So I'm going to go ahead and label the types of directions here, or types of motions. We have a constant velocity forward since we're above the x-axis, and we have a horizontal line. So we're pretty much staying right there at 5 meters per second for the first 2 seconds. Then we start going towards 0. Okay, so this is going to be slowing down forward. Okay, then at 3 seconds, we stop. So we have 0 velocity. So remember, pay attention to that 0 line. Okay, and then what happens is we start speeding up in the backwards direction because now we're in the negative and we're going away from 0. Okay, then from 4 to 5 seconds, we have a constant velocity backwards. Okay, so we're just staying at that -5 for a second. And then we start heading back towards 0. So this is going to be a slowing down backwards. And then we stop again at 6 seconds. So what is the maximum velocity attained? Okay, so you're just looking for highest y value. It can be positive or negative or both. So in this case, we achieved both positive 5 meters per second and we achieved negative 5 meters per second. Okay, both are equal, so both are acceptable answers, and you would need both of them because just because one is negative, one's positive doesn't make one faster than the other. Okay, it's just different direction. At what time was the maximum velocity obtained? Well, that was from 0 to 2 seconds and from 4 to 5. What is your velocity at 6 seconds? So at 6 seconds, I am right here, right there on the 0 line. So I can go ahead and kind of highlight that 0 line right here. Okay, so that's your 0 line. So at 6 seconds, I'm on the 0 line. So that means I have a velocity of 0 meters per second. When did the driver turn and decide to return home? That is right here where you crossed the x-axis. Okay, so that happened at 3 seconds. You went from a positive velocity to a negative velocity. When was velocity constant? So that's when you're looking for your flat lines. So that would have been from 0 to 2 seconds and 4 to 5 seconds. So 0 to 2, 4 to 5. What was the average velocity from 4 to 5 seconds? Well, I was -5 the entire time, so this is going to be -5 meters per second. Then what is happening at 3 seconds? We already kind of hit that. Okay, there's just different ways we can ask that. So at 3 seconds, that's when I stopped. So I had a velocity of 0, and I changed direction. Okay, during which intervals is the driver moving in the positive direction? So that means you're looking for above the x-axis. So when are you above the x-axis? That would be from 0 to 3 seconds. So 0 to 3 seconds. And then if you're in a negative motion, that means you're below the x-axis. And that would be from 3 to 6 seconds. Okay, moving on to this graph. Okay, so I have segment A, B, C, D, E, F, and G. Okay, so type of motion for A, okay, is a flat line. So this would be constant velocity forward. Okay, my change in velocity, that's just your final velocity minus your initial velocity. So that's 20 minus 20. So again, final velocity would be 20 at 10 seconds. Initial velocity would be 20 at 0 seconds. So 20 minus 20 is going to give me 0 change in velocity. Okay, my change in time, it took 10 seconds. And my acceleration is v divided by your t. Okay, so 0 divided by 10 is going to give me an acceleration of 0 meters per second squared. Then B, we actually start moving up. Okay, so this is going to be speeding up forwards. Okay, our change in velocity is, where did you end at? You ended at 30, and you started at 20. So 30 minus 20 is going to give me 10 meters per second. How long did it take? It took us 10 seconds. So 10 divided by 10 gives me an acceleration of 1 meters per second squared. Then from 20 to 30, it looks like we have a nice flat line. So there's going to be constant velocity forward again. Okay, and so what was our change in velocity? Nothing, because you were 30 the entire time, so it's going to be 0. How long did it take? 10 seconds. So 0 divided by 10 gives me acceleration of 0, which should make sense. If acceleration equals slope and you have no slope, that means you're not accelerating, you're not slowing down or speeding up. Okay, then line D. So be careful with this. You're not changing direction. You're just going back towards the 0 line. Okay, so this whole thing down here is the 0 line. If you're going towards it, you're slowing down. So D is going to be slowing down forward. Now your change in velocity is, where did you end versus where did you start? You ended at 0, and you started at 30. So 0 minus 30 is going to give me a change in velocity of -30. Now, how long did it take? It took us 15 seconds. Okay, started at 30, ended at 45. So -30 divided by 15 is going to give me an acceleration of -2 meters per second squared. Now, E, you got to be careful with this, is yes, it is a flat line, and your instinct could be to constant velocity. But if you pay attention, you're on the 0 line now. So you're actually not moving at all. Okay, so this would be called at rest. So it means no velocity at all. So what was your change of velocity? Nothing, because you didn't even have one to begin with. How long were you at rest? 10 seconds. And then 0 divided by 10 gives me acceleration of 0. Now F is we start going back away from 0, so we actually start speeding up forward again. Okay, our final velocity was 10. Okay, and then we started at 0, so 10 minus 0 is 10. And it took us 10 seconds to do that. So 10 divided by 10 is going to give us 1 meters per second squared. And then G, okay, we're back at a constant velocity forward. Okay, and then our change in velocity is nothing because we stayed at 10 meters per second the entire time. Okay, how long was it? 10 seconds. So 0 divided by 10 gives me an acceleration of 0. Okay, let's move on to the next page. So if I were to label the type of motion on this graph, I would say this would be slowing down forward because you're going towards 0. So remember, your 0 line is right here. I'm just going to highlight it. So if you're going towards it, okay, that's going to give you a slowing down. Okay, then if you're going away from it, so at 4 seconds you stopped. Okay, and then you start going away from it, so that's going to be speeding up backwards. Then you go constant 3, so that's going to be a constant velocity backwards. Now you start going back towards 0, so that's going to be slowing down backwards. Then you go constant velocity backwards again. And then you start going back towards 0, so that's slowing down backwards some more. And then at 14 seconds, you stop and you change direction. And now you're going away from 0. So this is going to be speeding up forwards. And then you're going to have a nice constant velocity forward to end it. Okay. Number 1, the velocity of the object from 6 to 8 seconds. Okay, so I just want to know what was my velocity at 6 to 8 seconds. Okay, so if you come over here, so here's your line right here. That is just at -3 meters per second. Okay, and let me go kind of clear up this a little bit so you can kind of see. Now what I am going to do is I am going to highlight this 0 line red again, because this kind of like gets lost because it wasn't super bolded, so our apologies for that. Okay, so number 2 is what is the velocity at 2 seconds? So at 2 seconds, I'm right here, so my velocity would be 1 meters per second. 3, during which time interval or intervals is the velocity constant? So we're looking for flat lines. So flat lines would be from 6 to 8 seconds. It would be from 10 to 12 seconds. And it would be 16 to 17 seconds. Okay, that's when you have constant velocities. What times is the object not moving? Not moving means velocity equals 0. So you're going to look, when do you cross the x-axis, or when do you touch the x-axis? That's going to be at 4 seconds, and that's going to be at 14 seconds. Okay, so 4 seconds and 14 seconds, that is when you have 0 velocity. During which time intervals is the object speeding up? So we're looking, you want to be going away from the 0 line. Okay, so we're going away from the 0 line from 4 to 6 seconds. And we're going away from it from 14 to 16 seconds. Anything else is you're either going constant or you're going towards it, which would be slowing down. The object's change in velocity from 0 to 6 seconds. So change in velocity is just change in y. Okay, so change in velocity would mean v final minus v initial. So my final velocity at 6 seconds would be -3 minus your velocity at 0 seconds, which would be 2. -3 minus 2 would give me -5 meters per second. So that would be your answer right there. Now, acceleration means slope. Okay, so what is the acceleration from 0 to 6 seconds? That's basically stating is what is the slope of the line that connects 0 to 6 seconds. And if you know these 2 points, you can just plug in a slope. Okay, this would be 0, 2, and this one right here would be 6, -3. So your y2 minus y1, so -3 minus 2, over x2 minus x1, so 6 minus 0, okay, which would give you -5 over 6. Now, we don't want to keep it in fraction form, so go ahead and solve it, and that would be -0.83 meters per second squared. Okay, number 8, the average velocity from 0 to 17 seconds. So again, you're just connecting the 2 points. Okay, so the point here would be 17, 1. So I already have my first one. So 1 minus 2, y2 minus y1, over x2 minus x1, 17 minus 0. So -1 over 17, and that's going to give you a -0.06 meters per second squared. Acceleration from 0 to 4, we already have it in a line, so let me kind of clear this up a little bit so we can kind of see. Okay, I already have a line, so I just basically, from 0 to 4, I just want to figure out what is the slope of this line. Okay, so my points would be 0, 2, and then 4, 0. Okay, y2 minus y1. Okay, so it'd be 0 minus 2 over x2 minus x1, 4 minus 0. So it'd be -2 over 4, so -0.5 meters per second squared. 10, the object's change in velocity from 8 seconds to 17 seconds. So remember, that's final velocity minus initial. Okay, so your final velocity was 1. Minus, where are you at 8 seconds? So at 8 seconds, you're at -3. So 1 minus a -3 is going to give me a velocity change of +4 meters per second. Now, when is the object moving the fastest? You're looking for highest y value, highest velocity. So anything above the x-axis, the highest I got was 2 meters per second, okay? But from 6 to 8 seconds, I got -3 meters per second. So that is my fastest velocity. So from 6 to 8 seconds, that is when you are moving the fastest. During which time intervals is the object slowing down? So that means when are you going towards the 0 line? Okay, so that's going to be from 0 to 4. Okay, then that's going to be from 8 to 10 and 12 to 14. So 8 to 10 and 12 to 14. So anytime you're going towards the x-axis. So 8 to 10 and then 12 to 14. And then does the object change directions? Yes, it does, because as soon as it hits this x-axis and goes through it, okay, that's when you stop and change directions. So there's actually two of them. So they stop and change directions 2 times. So one at 4 seconds and 14 seconds. So did it change? Yes. And it changed at 4 seconds and 14 seconds. And that'll end this one.